Anatomy. So today is going to be another notes heavy day, but it is a shorter notes day today than it was yesterday. I'm trying to get you all this information at first so you'll have plenty of time and you have all the resources that you need for your project next week. So please make sure that you have your notes and your packets out because you will need both for today. Okay. First up, I do need to make a bit of a correction on your questions page. You do need to cross out today's question that was supposed to be for next week, not today. What your question is for today is summarize action potential and impulse transmission in your own words. Okay, so if it would go, come on. Summarize action, potential, and impulse control in your own words. That is your question for today, and you will have plenty of time to work on this after we do our little lecture. Okay? So now that that is out of the way, let's get started with our notes. In yesterday's video, I talked about the different messages that the body sends. But what exactly did I mean by that? Well, the messages are information that your sensory or afferent neurons collect about both the insides of your body and how you're interacting with the outside world. So for example, right now you're sitting at a desk, writing notes and listening to me talk. You might be talking with somebody else, but we'll just say it's those three for right now. Your sensory nerves are receiving multiple messages from the outside world and transmitting that info to your brain. Not only are you getting info about the chair that you're sitting in, like how hard or soft it is, if it's warm, if it's cold, how much pressure you're exerting on it, so on and so forth. You're also getting information about the pencil or pen that you're holding, the brightness of the room, the volume of my voice, what I'm discussing, if it's hot or if it's cold in the room, and a whole bunch of other things from outside your body. But you're also getting info about your blood pressure, your heart rate, your hunger level, the position of your limbs, if you're tired, if you're awake, and so much more, all at the same time. So all of this information, all of these different signals is what I was talking about when I said messages. Your afferent nerves are sending all of this info to your brain, which is then decoding what each piece of info means, deciding what to do with that information, and sending a signal out to your body to do a specific response. So afferent nerves send messages to the brain. Brain receives and decodes, decides on what action it's going to take, and sends a response message. Sends a response message to your body. Okay, so it decides, it hears and sees and decodes all the messages that it's getting throughout the outside world and the inside of your body, decides what it needs to do, what it needs to adjust, what it doesn't need to adjust, however it wants to react to that information, and then sends that another signal out to the rest of your body through your efferent nerves. Okay? It is a bit confusing to think about and kind of to explain, to be honest. So we're going to explore an example. So say that you're sitting in my room, and for once my room is freezing cold, and I mean freezing cold. You're shivering and you're complaining to me, maybe you even see your own breath at this point. Okay? Well, your afferent nerves are getting the message that the temperature around you is cold and that your body is rapidly cooling down as well. And so it's sending, those afferent nerves are sending that information, those messages to your brain. Your brain is then getting those messages, realizing that your body is in danger of developing hypothermia, and realizes that it needs to do something in order to prevent that. So your brain then uses your efferent nerves to tell your muscles to start shivering, which produces heat. Or it tells your muscles in your arms to get a sweater or a hoodie and put it on to keep you warm. It also tells your mouth and your voice box to produce sounds that tells me that to complain about the cold and tell me to try to get them to fix it. Okay. Either way, your body reacted to a stimulus, which in this case was the cold, and responded. Okay. So now this is only possible because nerves have the ability to convert a stimulus into a nerve impulse. They convert a stimulus into an impulse. Okay. This property is what is called conductivity. Nerves and your nervous system are the only cells in your body that have conductivity, that are really good about having conductivity. Okay? Your muscles don't have it. Your muscles just react. Okay? So what exactly is a nerve impulse? Well, remember yesterday when I said that your body runs on these tiny electrical charges, and that if they were any stronger we would glow? Well, that's what I was talking about. Those electrical charges are your nerve impulses. Tiny. Okay. Now, these impulses are created when a neuron is activated. So normally, they're kind of dormant or inactive. They're just chilling. When it is dormant or inactive, there are potassium, K plus, ions inside the cell membrane, and sodium ions outside of the cell membrane. Okay. There are more sodium ions on the outside, so the inside, potassium, has a slight negative charge. Okay. Now, because there is a difference in the charge between the inside and outside of the cell membrane, it is considered to be polarized. Okay, so difference in charge between the inside and outside of the membrane equals polarized. Okay. So when there's that big of a difference between the charge, that's when it's polarized. So how does it become depolarized? Well, something, whether it's a bright light, a bitter taste, a loud sound, it causes the sodium channels in the cell membrane to open up. Hold on, I'm scrolling up just a little bit so you can see it. That wasn't just a little bit, but there you go. Okay, so the sodium channels in the cell membrane open up in response to a stimulus. That stimulus could be a whole bunch of different things. Okay. Because it's now letting this sodium in very quickly, it causes the inside of the cell membrane to become more positive. So it becomes more positive. And when it does that, it is considered to be depolarized. Depolarization creates a charge. And that charge is what we call our nerve impulse or action potential. Okay. Give you just a second to catch up. Okay, Ms. Gonzalez, you can pause here if they need a bit more time, but I do need to continue recording. So following the discharge of your action potential, the cell membrane becomes permeable to those potassium ions. If I could spell today. They want in. Or sorry, they want out. Not in. Sodium wants in, potassium wants out. It's like, see ya. Okay, the cell doesn't want this. The cell wants to hold on to those potassium ions. Okay, so it quickly begins repolarization. So it's trying to hold on to those cells. It's trying to make sure that those sodium channels close really quickly. And so it's not going to be doing anything but repolarizing. It's trying to hold on to as many potassium ions as it can. And while it is repolarizing, it cannot interact with another stimulus. Okay, so it cannot interact with another stimulus while repolarizing. And this period is what is called a refractory period. Alrighty, so for now, that is where we are going to stop today, just because I have run out of time with recording. So hold on to your notes. I know that it says nerve impulse, and we were going to talk about that with this recording. However, I did run out of time, so you can just write me a message for your grade for today, okay? That is going to be your compromise for your question. If you do have questions for me, remember to add them to the Padlet or come talk to me in class, however you want to do it. Make sure that you have gotten down the notes from yesterday and today. If you need to go back, you can do so as well. Hope you guys are having a great day. Bye.